filmed.
Awesome. All right, good afternoon, everybody, and thank you very much for joining us today. We're here to have a panel to talk about AI and how it can amplify the human experience. Some of the numbers that you may have seen being advertised recently is that it's predicted that AI will be a $13 trillion economy by 2030. Closer to home in Australia, there was a report that was released by Alphabeta last year that said that AI would be a $315 billion opportunity for Australians to take a hold of. And so today, I'm joined by some experts in D61's AI and machine learning group to discuss how it can amplify our experience. Directly to my left is Dr. Cheng Ong. He is the principal research scientist within D61's machine learning group. Next to him, we have Dr. Keay, who you may have seen speak earlier today. Keay is the research director of our cyber physical systems group, which includes robotics and cybernetics. And last but definitely not least, we also have Dr. Olivier Salvado, who is the group leader of computer vision and imaging at D61. My name is Alezeia, and I'm the product lead for also a machine learning program called Stellargraph, which is machine learning on networks, which you can see further down. So let's get to it. What I'd like to do is throw over to our panelists, because AI is such a varying area, and I want them to tell us who they are and what they do. So Cheng, let's start with you.
Hi, so my research area is in machine learning, and I spend quite a lot of my time working with scientists in other fields of science, such as genomics, systems biology, medical imaging, and astronomy. Now, what that means is essentially, as science becomes more data intensive, we're starting to use machine learning more and more to analyze the scientific data sets and to use machine learning to make predictions. Now, it's kind of important to remember that machine learning is purely about prediction. We have some data, let's say your genome, and we want to make a prediction about something like your risk of disease. Now, this prediction is never perfect, and the word prediction is also somehow not very accurate, but this is kind of the thing that machine learning is trying to learn from data, okay? Now, I'm also very pleased to be able to co-lead an activity that CSIRO is putting forward. It's called the Machine Learning and Artificial Intelligence Future Science Platform, which is a strategic investment that we're making over the next 3 years with tens of millions of dollars to try and push this agenda forward of using machine learning and artificial intelligence for scientific discovery. So I'll tell you more about this later on.
So I'm the research director for cyber physical systems within CSIRO's D61. And I like to think of cyber physical systems as just a flash way of saying that, we work with bringing the digital and the physical together. The sort of research that happens within my program includes robotics and autonomous systems, distributed sensing systems, imaging, computer vision, and cybernetics. And all of those things can be applied across all different industry sectors. So it's just fascinating to see where a lot of this technology might take us. Another way that I like to think of the work that our research program does is by simply calling it embedded artificial intelligence. So it's artificial intelligence that's being applied to physical objects.
And so I'm the group leader for imaging and computer vision. I'm working with Sue. And basically, we develop machine learning methods to analyze images. So either we have 3 categories. So we have technologies for when the videos or the images are coming from fixed camera in a facility like that, for example. The second category is where the video is mobile, so either on a robot or in an augmented reality setup. And the third category, we have a bunch of projects where we try to understand, it's a dedicated imaging equipment, such as magnetic resonance imaging or diverse scanners to measure and quantify objects that are known. And so either we try to understand what people behavior is by extracting the skeleton of when they do actions in 3D in an environment, or try to localize where the different cameras are in a scene, or finally to measure things happening, like rare events or objects in a scene as well. So there is lots of projects and lots of opportunity.
Is Isn't it just amazing how broad machine learning and artificial intelligence can be? Just with the 4 people on this stage, they're covering such a wide array of technologies and potential applications. The thing that gets me really excited is how we can actually grow this particular industry and grow the data science capability within Australia. So within the program that I work on, it's all about trying to grow the data science capability within the public service by using graph technology to take lots of different data sets, connect them, and create a 3-dimensional model so you can then gain greater insights from the relationships. It's the kind of thing that gets me up in the morning. Cheng, what's the thing that gets you up in the morning? What excites you about this industry?
So I think it's worth thinking back a little bit. What we think of as scientific discovery today is roughly 400 years old. It's almost exactly 400 years ago that Francis Bacon proposed this idea of scientific discovery, where on one side you have data, and on the other side you have knowledge. And to go from data to knowledge, you do this thing called observation. You observe the world to gain knowledge from data. And machine learning so far has really been focused on applying computational tools to go from data, to understand the data, to gain knowledge. Now, there's the reverse side, which is to use the knowledge that we gain. So remember I said machine learning is about building a predictor. When you have a predictor, you have this knowledge embedded in your machine learning tool. You can use it to go from knowledge to data, which is you can ask questions like, where should I measure? What type of data should I get? Where is the most value for money that I can use to go that way? So, and that side of scientific discovery is not just limited to science. I mean, it's applying everywhere. You can use it in industry, health services, government, wherever you like it. This question of where should we measure such that we gain the best bang for our buck?
That's awesome. And Olivier, when we think about autonomous vehicles, obviously computer vision plays a big part of that. What else can you use with that tech, and what's going on in that space at the moment?
So those techniques are used for not just autonomous cars. They also apply to autonomous vehicles that are used for agriculture, for example, or surveillance of geographical imaging. But there are lots of applications where we want to understand the behavior of people. We want to detect if it's a safe environment for people to work, or to detect how many objects are in a scene. And this for example, the hospitality industry, so restaurants, how many customers are present in a restaurant at a given point in time, or in a factory, how many people are moving sensitive assets. There is also there are other applications where one of them is agriculture. So agriculture uses a lot of computer vision to estimate yield of crops, to move autonomously tractors, to understand the science behind the plants and the food that we are eating. And another big area that takes a lot of projects on energy at the moment is trying to quantify radiology. So medical imaging produces a lot of MRI, PET scans, CT scans, and that creates lots of images. And the current way, or the traditional way, is for radiologists to spend a lot of time doing very tedious look at hundreds of slices of the brain or the body. So all those tasks can be quantified by AI now, and there is an awful lot of startups and projects that demonstrate that medical imaging can be quantified to support and help the radiologists to do the more interesting stuff and to increase the number of people that can use those technologies, those medical technologies.
And so just for the rest of the audience here, so computer vision, is that camera technology that's observing the world around us? Is it technology that's crunching the information from it? Is it a combination of both?
Right, so we are looking at sometimes specialized cameras, so like a hyperspectral camera, which are not just taking red, green, and blue, but hundreds of different colors. It comes from video, but there is also data coming from LiDAR, with laser scanning for 3D, stereo imaging, and of course all the medical imaging parts are 3D data sets. So we get a cube of data sometimes over time, which complicates, of course, everything we do, and you need more memory, more computer.
Okay, excellent. And I guess one of the things that we find when we think about software development or machine learning is sometimes it isn't always very visible about what we do. But Sue, when we think about robots, they're such a visible thing, the tangible thing that people can really get a hold of. What are some of the big developments that you've seen in your space?
So one of the biggest changes is going to be, I think, how we view what robots are. So, I guess up until now, there's been a lot of work in developing different types of robots that can do different things, but we're now starting to get to the point, as we've seen with self-driving cars, where you can just turn commodity products into robots. And I think that that's going to open up a lot of opportunities. So, you can imagine if you could make your chair a robot, there might be a lot of interesting uses you could put that to. But rather than us actually building everything from scratch, more about how we can work with what is actually already in existence and serving a useful function and just making that autonomous.
That's super cool. So can you give the audience some other examples about how we might take a normal object and then kind of turn it into a robot? Is there some tech that we've got that does that?
Yeah, well, one example would be in the logistics area where you might need to move material from one spot to another spot. So you can imagine that if you were shopping or there, you might look at how you could have an autonomous shopping trolley that could do, rather than having a human pushing it around, it could actually be finding its own way around. And without having to reconfigure all the shops, then you could just use the existing technology but make it a robot. And that also makes it a lot cheaper, because at the moment we use what are called AGVs, or automated guided vehicles, and typically each unit would cost about $100,000 at minimum. And then you'd have to pretty much design your factory or warehouse or your logistics space to suit that AGV. Whereas if you could just make the material and the trolleys and other things that you already have in your warehouse into robots, you can imagine there's a lot more things that we could do.
And do you feel that, if we're talking about how AI and machine learning can amplify our own human experience, if we've got an aging population, do you feel that this kind of tech might be really supportive and helpful for them if we can take things that they're used to and then help automate them to make their lives easier?
Yeah, and I used an example in my talk this morning of companion robots, and I do think that we're going to see a transition from home assistants into robots, because really all that's doing is about making your home assistant vision-enabled using some of the technologies that Olivier specialises in, and then making them mobile, so that they can be walking around or moving around the house and keeping an eye on things. Because I think you could probably appreciate that you could achieve the same ends by completely censoring up your house and putting cameras everywhere, but not many people feel very comfortable with that. But they probably feel quite comfortable having an assistant that is wandering around just making sure that things are okay, but it's not like having eyes on you all the time.
And that brings a really interesting topic into the forefront. A lot of the time we speak about ethics in machine learning and AI, but that starts to bring in the concept of trust. So how do we trust the robots? How do we trust the data that has been generated by algorithms? I know a lot of the work that we do in my team, because it is in high consequence situations where the data that is presented based on predictions, you might have to make a decision that could lead to a high consequence outcome. We do a lot of research into how can you help people trust the data? How do they need to interrogate the data? I'd really love to throw the question out to the rest of the panel and see, in your work, has that come up, and what are the kinds of things that you're experiencing? Cheng?
So I think one of the things about trust is this question of being able to understand what the machine learning algorithm is predicting, such that it helps us make good decisions. So you can do this in multiple ways. One way we try to do this, and this is a very statistical view, is that when the machine learning algorithm makes a prediction, it also reports its uncertainty or its confidence, if you like, whichever way you like it, about this prediction, such that you can use it in downstream decision making. Now, how to calibrate that uncertainty is a big and difficult question, because part of it is to understand the consequences of the decision, okay? So I like to use this analogy, and then I don't know how many of you can remember from high school statistics where you go, there's type 1 and type 2 error. There are two types of error that you can make when you make a decision. You can make false positive and false negative decisions. I could never remember what that is. So the way to remember it is there's this story of the boy who cried wolf, right? The villagers first made a type 1 error, and then they made a type 2 error, right? First, they believed that there was a wolf when there wasn't a wolf, and then they believed that when the wolf finally came, they didn't believe that the wolf came. And in some sense, when you use machine learning predictions to make decisions, you make both those kinds of errors, and you have to trade off one from the other because you cannot get both of those errors down to zero. And I think this is the kind of fairness type question we have to answer.
So that kind of leads to maybe not just necessarily trust, but trustworthiness. So how do you make people, how do you build trustworthiness in the system so they can actually take a decision? With autonomous vehicles, Olivier, you must have to deal with this all the time as part of computer vision. So if an image is presenting itself and you've done some kind of processing, how do you build that trustworthiness that people will act or understand or take advantage of it?
Yeah, no, that's a big topic, and Cheng soon explained a few areas on that which apply also to that case. But the reality is that most of the machine learning that is used at the moment is supervised. So that means you have a very large data sets which have been labeled, which means they have been put in two buckets, and you train a computer over millions of hours of computation to recognize a pattern in the data that are associated with either the blue team or the red team. And the computer just, when you present a new data set, just tells you which one is the label the most likely according to what has been seen in the training data. So, and this is how things work most of the time. The problem is that for developing autonomous vehicle, for example, you would have hours and hours of video, and then the system would be able to learn from those videos. And if you compare that to a human, so you get a teenager who can learn to drive a car in probably 10 hours, and then assuming you trust your teenager, that teenager would probably be able to drive that car in a different countries or in a different scenarios. Whereas the computer, even though you spend those millions of hours training on that particular data set that is coming from a German database with German sign on roads and driving on the right, the same program driving a car in Sydney would not be very trusty. I wouldn't trust that car to sit on the passenger side. So I think there is a big gap between what the computer can actually do, which is just reproduce at the moment what has been seen in the training data, with what is the expectation of people. So when you get into a car, the car has been seeing millions and millions of hours of driving. That's what Google is doing. They have cars driving everywhere to get the training data sets. And trust would come where perhaps we get a next level of intelligence where the system would have some kind of understanding of the basic rules or use common sense. At the moment, the machine learning system, the best one is probably much stupider than the worst rat. A rat is much more intelligent than any system you can develop. So this is a big topic of research.
I mean, that's really interesting when obviously the work that CSIRO and D61 does is very much based in deep research. And while we've made such great headway, it still sounds like there's so much more that we need to do. Sue, as the research director of the robotics group, what are some of the key areas that you think we need to start research on, or are kind of the next emerging areas?
Well, if I say the application of computer vision to robotics, then Olivier's going to ask me for more money. But obviously we're increasingly applying techniques like deep learning to robotics, and to good effect. it just increases the speed with which robots can learn the tasks that they need to accomplish, and decreases, the amount of complicated coding that needs to go in, and also enables the robot to really modify its behaviour depending on the circumstances in ways that haven't been possible before deep learning was applied. And that really has only happened in the last 5 years. So that's been a significant change to the way a lot of that research is conducted. And just to give you a little preview of a talk that you have to go to tomorrow morning by one of our researchers, David Howard, I think another really interesting area is the application of machine learning to the design of our robots. So David has been applying machine learning to first work with our materials scientists to look at what composition of material we should use to create a robotic component, depending on what we want that component to do, and then applying machine learning to determine the shape that that component should be to achieve its objectives. And so you can imagine we can come up with some pretty funky designs using machine learning that perhaps it would take a human some time to think of. And then finally, David is using machine learning to actually get that robotic component to train itself up on how it's supposed to behave. So really, we're just skimming the surface now on the sort of opportunities that are going to be available to a lot of these physical systems by applying machine learning.
Someone literally asked me at a conference last week about could machines actually start designing things. So we say now that that's an active area of research, that you could use machine learning to design new products or potentially houses or areas that we live.
Yes. Or as Olivier was pointing out with this afternoon's afternoon tea, lamingtons. I think round pink lamingtons don't work for me, but Olivier did suggest that that was probably some machine learning experiment.
That's a test. We're testing to get some more data on that straight away. Excellent. And Cheng, what about you? So if we think about where the research is going, in the area that you work in, what are some of the things where you see the research going in the next 2, 3, 5 years?
So there are different ways to answer that question. So at some sense, I work a lot with people who look at the fundamentals of machine learning. So these questions about what is learnable, what are the limits of learning, how do we encode the things that we take for granted, the intuitions we have, into a function, it's often called the loss function, such that the machine learning algorithm can attack this problem. So those are the very fundamental questions. But I think given all the successes that machine learning has had so far, I think it's somehow surprising when I say that actually we can only solve a very, very small number of problems with machine learning. If you have a problem that we can convert into something called a classification problem, something with a small number of categories, machine learning can solve it. But when you leave it, for example, if you want your classification to be somehow unsure, right, to allow more than one possible category for a particular object, this already becomes quite a hard problem. So in fact, a lot of the machine learning research today is about extending the types of problems we can solve with machine learning. So instead of going from classification where you either have to be a dog or a cat, maybe we can look at, kind of hierarchical things. It's a cat, and maybe inside the cats we have, tigers, house cats, and different types of cats. So these more fine-grained things are what we need as a society, and these are essentially open problems in machine learning.
Excellent. And Olivier, what about yourself?
Well, so to go back to my story about the driving, I think the fundamental question that lots of people are thinking about is what kind of techniques do we need to invent so that a computer can learn by itself to drive a car in 10 hours like a human does. And there are I would say two broad categories. There are people thinking it's just a matter of complexity. So you just throw more neurons on more layers on slightly different tuning of stuff, and eventually it would come out of this black box. And there are other people who say this is not possible. With that stuff, you would just be able to find patterns. We need something new to generalize the training and to go to general intelligence. So this is one big question. Other big questions are related to that. Is how do you do the training when you don't have a lot of data or when you don't know what you are looking for? Right? Medical applications are especially accurate in that because the data set is so more limited. There is lots of variation. And nobody knows, well, it's very difficult to know what you need to learn. Right? Doctor might tell you what they think it is, but you actually don't know what it is. So learning on the uncertainty with very limited data, almost no training data set, this is a very exciting area.
Absolutely, and certainly the area that I've worked in, which is linked with law enforcement, there is this really interesting challenge that there isn't a ground truth. So machine learning tends to be quite data hungry, and you need to have lots of data to train it on, and you also need to have what is known, what is a ground truth. And if you don't have that ground truth, how do you then train the model? And so this is where we start thinking about, we've got to give it information that we have, so things that we determine are high risk, or things that we might determine are most likely. And that's a big challenge for us at the moment that we're trying to unpack, is how do you train things to happen when you don't have the underlying absolute ground truth? Because if we think about what we do as humans, sometimes we go, oh, I reckon that this is the way that we need to go forward. And you have a gut feel, whereas the machines obviously don't have a gut to go on the gut feel. So we've got to give them an approximation. What I want to do for the moment is, because we've got 45 minutes scheduled for this, we want to make sure that you all get the opportunity to ask us questions. So I'm wondering, is there anyone in the crowd that would like to pose questions to the panelists while we're up here? Otherwise, we could keep banging on for the next half an hour. Do I have any hands that have any questions that they want to ask? We do have one question down there. I think I've got a roving mic. Matt, I think there's a guy over here to your left.
Hi, I'm Siva from TCF Services. I've got a question regarding trust and ethics. So the ground truth that you're talking about, how do you establish that? Or is there some metrics that we are looking to establish so that the research can be progressed in that direction?
Oh, that's a really great question. We could probably throw that out to everyone to have a comment. I'll start off. So in the area that I work in, there isn't always a ground truth of what has actually happened. If you take the example of imports, we've got people that need to potentially check all mail items that come in. Is there anything dodgy coming in? We can't check every package, so there isn't a ground truth to say what was 100% okay and what was not 100% okay. So you need to start with some kind of risk factors. And to Olivier's point, one of the things that we're trying to do is work on how do you establish a ground truth when you only have an indication of risk. It's certainly an open area that I'd love to discuss with you after. Does the panel have any other comments on that space?
Perhaps it's worth mentioning another one way to go around this problem of ground truth is to create your own data. So if you have enough knowledge about what you are looking for, let's say, for example, you want to find lesions in the lung. I see my colleague Julia who is working on trying to detect lung cancer. So if you discuss with doctor and you come up with a model of lesions that you expect to find in a lung, what you could do is to take normal lungs for which you have a lot, and then create 1 million different lesions of what you think the lesions is. And because you created the data, you would have the perfect ground truth. And then you can use this massive data set to train your method. So of course, this is going to be working if your model and what you create is realistic. But that's a good way to bootstart your training and maybe do most of the training on that big data set and then finish on real data, which are more expensive to get.
Just to answer that, there are also two parts to this question about ground truth. One part is this question, so machine learning has an algorithm, but at the same time it uses data. And so one challenge we have deploying machine learning is to understand the biases we have in that data set. And because very often the data that you use to train the machine learning model isn't actually the kind of data you're interested in. You often train it on some model. Maybe it's based on data collected in the USA, but you want to apply it to the Australian context. And that bias that you have from the American data is something you want to figure out how to do. The other part, and maybe Sue can comment a bit further on this, is very often we don't have ground truth for every single step of the thing we want. You know, we might have to take a sequence of 5 or 6 steps to reach that final outcome, and where we might be able to measure ground truth at that final outcome. But we don't have ground truths on all the earlier steps. And this is very common in robotics, where there's a goal you want to achieve. You get points if you reach the goal, but nobody tells you all the intermediate steps that you have to do to reach the goal. And so ground truth is tricky because machine learning is data hungry. You want to add something?
Awesome. Do we have any other questions at this point? Yes, the gentleman over here in the middle.
Hi, John Murray from PainCheck. Where do you think we are in the evolution of unsupervised machine learning or semi-supervised machine learning? And how are you seeing that being applied?
Great question.
Yeah, I can start with that one. So I think it's a bit linked to the ground truth problem. And so there are lots of people thinking about developing techniques which does not require ground truth, which doesn't require labeling data. So one exciting field at least in imaging is self-supervision. And here what you try to do is so I think it comes from observing a baby learn the world, right? So a baby would build very quickly in his brain or her brain a physical model of the world. He would know that at one point his brain would understand that if you drop the bottle, it would go down, it would not go up, and you can see that because at a certain age, if you drop a bottle and then you trick the bottle to go up, the baby is going to laugh because he knows that the bottle should go down. And so there are techniques that try to move into that direction. And for example, you could take a video and then from one frame try to predict what is going to be the next frame. And you can try to do that with further and further frames that are further and further along. And the idea is that if you can predict that very well, somehow in the model you would have a physical model of what's going on. You would know that if you see a person walking, then that person should keep walking in a particular direction. So I think this is a step in the direction of trying to be a bit more general, to have a bit more general model to understand and to generalize your learning. So that's called self-supervision.
Any other questions from the audience so far? One down the front.
Hi. You mentioned before about the bias that comes in from using certain data sets. And I was wondering if you had any ideas about how we can remove the innate sort of bias that we all bring to the research that we do.
That's a really great and layered question. I know that there's a number of institutes that are now looking at unpacking bias in an ethical way and building machine learning algorithms that are ethically considered. I think before we answer the technical question on the data, it's also interesting to consider that building these algorithms and tools for the future require lots of different data sets, but also lots of different diversity in teams to try and acknowledge and understand what is that bias and how do we remove it. Some of the great work that I see within D61, we don't just have data scientists and engineers, we have UX researchers, social researchers, product people, people that are really looking at, that are data experts, but are also people experts, so we can identify where we might have gaps in our knowledge that we need to fill. I might throw it over to Sue and maybe have a comment on some of the questions around bias and ethics, if you'd care to comment.
Well, I'm not sure there's a good answer for that yet, really, in terms of how you can, apart from by having diverse teams involved in when you're first looking at how you're going to solve that problem, it's a pretty difficult thing to unwind, particularly because a lot of our data sets inherently do have bias, and sometimes it's not easy to recognise or remove.
Yeah, 100%. So what we're finding is that there is anthropological knowledge plus the technical knowledge. So a lot of where machine learning has gone wrong is because they've always looked at how society has acted or has been processed before, not what we want it to be in the future. And so I think it's when you're first designing these systems, it's imagining what do we want the future to look like? So what might the gaps be that we need to consider as we design the systems for the future? And I know that there's a masterclass tomorrow, which is kind of thinking about that exact problem, which is about future state design, not just taking the status quo, but what could the potential future look like that you could consider. While we wait for, I'm sure there's a couple of other hands going up in the audience, but I'd love to poll the audience ourselves. I'd just love to get a raise of hands who's actually with a data science or technical background who is actively working on machine learning today. Can I get a, oh, so there's a few hand wavies. Okay, and I guess for the rest of the audience, are you people that are investing or looking at bringing machine learning into your business? Hand raise for that. Okay, and otherwise just really curious about how our fundamental humanity might change with artificial and machine learning. Anyone in that? Oh, there's a few. Yes, one definitely, hand up there, excellent. And a few over here. Look, I guess for the panelists, I'd really love to ask you a question. If we're here to discuss artificial intelligence and how it can amplify our own humanity, what do you see as the ideal future? Do you have a vision of what an AI-enabled future looks like for everybody? I'd love to just go through the panelists and get their thoughts. Cheng, let's start with you.
I think the way I see it is machine learning and artificial intelligence is a technology very much like all other technologies we have. If you think back, the time before the slabs of glass that we carry around with us, this is a thing of technology, and we now learn to live with this. So I think, if anything, it's another technology that we're going to use and understand well. And I think what's super important for me is that for everybody to be somehow educated and understand a little bit about the impacts of using machine learning systems in our society, because it is here and now, it is being deployed as we speak, it is used to recommend books that we read, it is used to make decisions on social security, it is used in a lot of situations that whether we like it or not, is going to be part of a society. Now, I think as part of an educated society, in my ideal world, we all understand the implications of what this means. Now, a lot of these implications are subtle, and I'm not claiming I know the answers to most of this, but I think it's important as a society to know the implications of deploying these systems.
Excellent, thank you. Sue, what about you?
Oh, well, I agree with Cheng that it's critical that we bring everyone along on this technological journey with us, and so the better that we have technological literacy at all levels of society is critical. But I think that alongside that, we also need to be thinking big. So where I see the real advantages of the sort of technologies that we're developing within CSIRO is that we have an opportunity to not only augment human potential so that we can do more things than we've ever been able to imagine before, but that we can do it at scale. And so if we can really push these technologies forward, then we should open our minds to the possibilities of what we can do and what we want the world to look like. Because I think we should be applying these technologies to having more inclusive societies, to giving people from disadvantaged circumstances to be able to flip that so that they have the tools within their own hands to help make the world a better place, so that we can help protect the environment and actually restore the environment in areas where we haven't been doing such a great job, so that we can tackle the big questions like climate change, war, famine. You know, these are all the sorts of things that we really should be having a hard, I guess, think about. If we can really push these technologies forward, what can we do with them? I mean, already these technologies are going to be used to help us to create a lunar global village and take the first steps towards having missions to Mars. So, the sky's the limit, and that's what we should be aiming for. We should be aiming to be building the planet that we would all most like to live on.
Yeah, so perhaps in addition to that, I think the current state of the technology at the moment is a bit like medicine was 200 or 300 or 400 years ago, where it's a bit the Wild West, where people do experiment and there is very little, not entirely understanding what's going on. There is a little laws, and I'm not confident when posting anything on Facebook. I'm not comfortable sending my saliva to 3andMe to scan my DNA. And I think the legislation on the guidelines on ethics are lagging the current technology. So I expect that it's going to take a while, but eventually we would have robust laws that allows to deploy AI and where the people would be confident to share their data. They would be confident to know what's going on with their data. They would be comfortable knowing that their insurance is going to cover if something happened that was not planned. Medicine came up with this level of deontology. So all the doctors have to take to swear on Hippocrates, I think, sermon. And I think we'll end up with the same situation. It's a technology that can have a lot of application, but the current legal and the current legislation is completely lagging the capabilities that we can have at the moment. So.
Yeah, absolutely. And I think the thing that always comes loud and clear through these kinds of conversations, which I love having, is that it's always human first, but digital by design, and that this isn't just building technology just for technology's sake. We are trying to make the world a better place that is more inclusive, and this is one of the technological tools that we can do to get that to happen. I'm also really fascinated that a lot of the questions are around bias and ethics and semi-supervised and supervised learning, so it's not just let the robots go and do their thing. Everyone else is also really interested in that human first but digital by design. Look, we're almost out of time for today, but I recognize that many of you may have lots of other questions. I know that whenever I walk away from a session, I get 5 that pop into my head. There is a networking event later on today that starts at around 5. Many of the panelists will be still around. So if you do want to come and approach them and ask them a question, please do. Otherwise, there is a website that's called Expert Connect that enables you to connect with researchers from not only Data61, but all around the globe that do this research. And so please do reach out either through LinkedIn or through the networking. So please join your hands in thanking Dr. Olivier Salvado, Keay, and Cheng.